project is Smart Light Motion Sensor, and this sensor will automatically control lighting based on human movement and human motions. It is aiming to reduce unnecessary electricity usage in campus facility. The background of the problem is UTM is a large university with many facilities requiring continuous lighting, so the lighting contributes significantly to the university electricity consumption. Many areas still use manual or fixed reduced lighting system, then the light will often left on even when the room is unoccupied. Why this project is needed? Because the manual switching depends on human behavior are unreliable, and the next, the energy is wasted due to negligence and lack of monitoring. Even with a LED light, poor control will cause unnecessary power usage too. The scenario example is a classroom is empty between lectures and the light is remaining switched on for hours. No one is responsible for turning it off. So this is the result in unnecessary energy consumption. Our proposed solution is we implement an automatic lighting system by using IR sensor to detect human movement and motions. And the last, we control the light using microcontroller and relay module.
Okay, moving on to the benefits of the prototype. The first one is reduce operational electricity costs. Since our system is more focused on automated lighting, it can reduce unnecessary power wastage in classroom, corridors, and large areas to lowering the institutional energy expenses. The second one is our system can provide a more efficient campus energy management since its motion-based control minimize reliance on manual switching and reduce energy wastage across large facilities. Next, our prototype also align with sustainable development goals, especially SDG 7, which is affordable and clean energy, since it promotes the efficient use of energy and access to reliable and sustainable electricity. It also aligns with SDG 12, which is responsible consumption and production, which encourage organizations to minimize waste and use resources wisely. Lastly, our prototype use easy and convenient lighting control since it provides integration with the Blink application to allow lighting system to be monitored and managed remotely using a mobile device and reduce the need for manual intervention.
Okay, so now let me explain the component that we use in our IR sensor light system. So first of all, this one is the light bulb that will turn on when the motion is detected. And then this one is the IR sensor. So basically it will detect the motion using the infrared light. So when something comes close to it, it will send electric signal to the Arduino board. And then this one is the jumper wires and also the insulator. The red one is the insulator tab to make sure that everything connects safely and to prevent like electric shock or what. And then this one is the ESP32S3 that we use. And then this one is the relay. So basically it acts as a control switch. So when the sensor sends signal, the relay will turn the light on. Okay, and then this is the USB-C cable that connect to my laptop, basically to power the ESP-S3. So there are 5 volt from the laptop, and the ESP32S3 has a regulator that will convert to 3.3 volt, which is what the chip actually used. And also I use this USB-C to upload the code and also for serial monitoring. So right now, okay, so as you can see, when the IR sensor sends motion, it will send signal to the Arduino board and the relay will turn on and then the light bulb will later on. So now let me explain so basically I use this Blink app to monitor the condition of the IR sensor light system. So the app. So basically it will send a notification every time the motion detected. And then the LED condition here is the LED condition. So basically, if it's on, it will turn yellow. And then this is the connection status. Oh my. And then this is the history of the motion. Like basically, it will run when there is motion detected.
The prototype performance, we want to see how long it takes for the light bulb to turn on and off. And for this part, we can see that it turns on almost immediately and also turn off immediately after detection of my hand here. So now moving on to the next part, which is the detection range. So as we can see, it can only detect until about 8 centimeter. So, and past that, it cannot detect any movement or obstacle.
So, if we apply, let's imagine that we apply this prototype in toilet. So basically, when if this is a toilet, and then when someone comes in, the IR sensor will detect the object, and then the light bulb will turn on. And after she uses the toilet, and then after she go out, then the light bulb will turn off automatically to prevent energy waste.
So our limitation of our prototype is that our sensor need to be placed on a dull surface. If it is placed on a reflective light surface, then it's going to cause our light bulb to turn on. This is because a light reflective surface will trigger the IR sensor by giving it reflective infrared ray. So, because of that, our light bulb still turns on even though there is no obstacle in front. From the observation, it is shown that the prototype exhibits a fast response in object detection. The effective operating range of the sensor is approximately 8 cm. However, the light bulb may remain switched on when infrared radiation from other sources is detected. Therefore, a proper sensor placement is really important. The sensor should be directed towards intended motion area and positioned away from sunlight, heat sources, and reflective material. In addition, the detection path should be kept clear from any obstruction to ensure accurate operating performance.
So this ESP32S3 BESS IR motion sensor lighting system can support the Malaysia Smart City initiative by improving the energy efficiency through automatic motion BESS lighting control. The system reduces electricity wastage, enhances safety and convenience, and contributes to smarter and more sustainable urban infrastructure.
Alright, we talk about the future recommendations of this product. So we plan to integrate photocells, which will allow the system to detect natural light levels. So this ensures that even if motion is detected, the artificial light remains off or dim if the room is already sufficiently lit by sunlight, which further maximizes our energy savings. So next, we will be talking about the incorporation of smart dimming technology. So instead of for example, you walk through the sensor, okay, it detects, when you refer to the sensor, it detects light, but when you go away, it's switch off. So that's actually kind of a bit hard for those who wants the light to stay on for a long time, especially when you go into the bathroom and then you just sit down on the toilet seat and then also the light switches off. So we plan to implement a system where if you walk past the sensor, it will have a time where the light remains on for a long time, and then when you walk past the sensor again, it will switch off. So that this will ensure that there's actually usage for the system and it doesn't just switch on and off if someone just walks past the sensor. Another feature we plan to implement is to add AI and predictive analytics so that we can analyze the motion history of the history collected via the Blink app. So the system could predict peak occupancy times. So this allows the university to preset lighting schedules for high traffic hours while maintaining strict sensor-based control during off-peak times.